Hello everyone, and today we're gonna look at min-max normalization, which we could compute using this equation here. So xn is our normalized data, and x over here is the input data. So we subtract the minimum of x from x, and then divide it by x max minus x min, which is equivalent to the range of the data. So in this example, we'll use the above equation to normalize the data x that we have listed here in this table. And then once we'll get the normalized data, so which would lie between 0 and 1, so we'll update that data so that the new normalized data would have the minimum as 3 and maximum equal to 7. So this is a hint showing how to accomplish this task here. And once we complete task B, we'll uh, convert the normalized data from B to its original form X, that is this column here. Okay, and um, in this video, we'll only use Python without any numpy or scikit-learn libraries. So here I have listed x equal to uh, all the data set that we have, and yeah, let's get started. Okay, so um, let's first save the minimum and maximum of our data um, into new variables and also the range of data, so which is x max minus x min. Okay, so now that we have x min, x max, and x range, we could calculate the normalized function using normalized data using the map method, and map will provide a lambda function here which will use the x min and x range, and the input to the map function is x. If we run this, so now that we have the normalized data, so let's see how it looks. For that, let's write another lambda function here. So that reduces the data to 2 decimal points. And if we look at the data, this is how it should look. We could also write a function, min max normalize, that has the data, the x min and x range in its arguments, and then returns x min or x range. And we can import another method partial from functools and create another function. So min max norm, which is partial, um, and we do min max normalize, and x min of that argument is max min that we have stored our in cell 2, and x max is equal to x range is equal to x range. Um, so now that we have this function here, um, so the reason of doing this is that now we could use this in the our same map method as instead of this lambda function here. Um, we could also use a for loop and use the function that we have written in cell 5. So, for example, x and a is min, max, normalize. So x and then for x in x, and it should return the same uh, values. Uh, we could also write it now as a lambda function using the this modified function that we have written using partial. So we say min max norm only instead of that lambda function, and provide x as input, and we get the same response here. So all these three different ways we could use to calculate the normalized min-max normalized values for the given data. Okay, so let's look at task B now. Okay, so let me set a comment here. Task A. Okay, so for task B now, we want to update this normalized data so such that the minimum value of the new data should be equal to 3 and the maximum value of the new data should be equal to 7. And we'll use this hint as provided here. So let's start with task B. And yeah, let's create some variables x min desired, x max desired, which is 3.0 and 7.0, and x range desired would then be equal to x max desired minus x min desired. Okay, and once we have that, we could create our new normalized data using lambda equal to, which should be x min desired plus x range desired multiplied by x, and the input to that should be x and a. Okay, so we got our normalized data, and if we want to see how does this look, so x and b here, and this is our new data. So you could see that the maximum value prior to this normalization was 1 and the minimum was 0. So now the minimum is 3 and the maximum is 7 here. Again, you could try to use a function, a for loop, to do the same. You could try that as well. Okay, let's see if we could convert the normalized data from B to its original form. Okay, so in order to do that, we just need to uh, do all the processes backwards. So, for example, we need to convert this data to this data and then uh, to our input data. So, let's look at it again. List map, lambda, so x. So we have x min desired, so we'll be subtracting x minus x min desired. So here we are multiplying x range desired, so we'll have to do x range desired. We have to divide it by x range desired. Now this x is also normalized, so which means that it's also in this form. So x minus x min divided by the x range. That is these variables here. So we'll have to multiply this one with x range and then add x min. So this is a long lambda function, so perhaps you want to write it as a separate function and then include it in this command. But for now, I'm doing it like this. So x and b, and close the map function list call, and let's call it x hat. Okay. And if we want to look at this x hat data, so it's exactly the same as listed here. So minus 1.87, 3.61, 1 minus 1.52, and the last entry is minus zero point zero 0.06 and 1.72. Okay, so yeah, so these are different ways we could use only Python without any numpy or scikit-learn libraries to do min-max normalization. Um, I hope you liked today's video. Thank you for watching, and see you in the next video where we would be using numpy and scikit-learn to do the same exercise. Thank you.